Alrighty, kiddies, here we go again. This is Mr. Key. I apologize. I've been a little under the weather, so I'm only getting these out a little bit slower than I normally would be. I've already done 1 through 14, so this one will be 15 through, 27 or something like that? I don't know. Let's just get going. Hopefully you did okay. It wasn't that bad of a test. I think I've done all these. There we go. So the formula for the nth term of the geometric sequence, now I know it's a geometric sequence, they didn't tell you, but it looks like we're multiplying by, notice it's going back and forth between 3, or negative, positive, negative, positive, negative, positive. So therefore we're multiplying by negative something. So only ones with negative I really want to think about. So I'm not even going to think about these, but wait a second, they might be the answer. I'm not really sure. I got to be really careful. Because this one's got an, you know what, I'm going to be very careful. So I'm going to plug in a 1 and see what I get out, because that's the first term. I plug in a 1 here. I get negative 2 times 3 to the 1 is 3. So negative 2 times 3 is negative 6. That's not it. Plug in a 1 here. I get 3 times negative 2. That's negative 6. That's not it. Let me plug in 1 here. So if I plug in 1 here, this becomes a 0. So 3 to the 0 is just 1. 1 times negative 2, negative 2. It looks actually, this might be the right answer. Let's check it out. We put in a 1. So this gives us a 0. Negative 2 to the 0 is just 1. 1 times 3 is 3. Ah, that worked. So now let's put in a 2. So we'll plug in a 2. So this becomes a 1. Negative 2 to the 1 is negative 2. Negative 2 times 3 is negative 6. Let's do it one more time. Let's plug in a 3. I'll plug in a 3. This becomes a 2. Negative 2 squared is positive 4. 4 times 3 is 12. And there, my friends, is your answer. Ooh, almost lopped off one of the wrong answers. Here's another one. You could have just plugged in any value for A and any value and then typed it in, and then you'd have gotten 0, and then if you type in another value for A, you would have gotten 0, and you type in another value. Now here's why it's 0, because this is backwards. So if I turn this around so that it's really A minus 1, that's the negative 1 rule, which means you have to include a negative. So I'll put it right up here on top. Well, now that they have a common denominator, I can add the numerators, keep the denominators. 3 minus 3 is 0, over A minus 1. 0 is the answer. So here's another one. If you just put it in your calculator, you might have been tricked into thinking the answer, I think, was 3. I think they tried to trick you into thinking the answer was 3, but I don't think it is. So let's do this the correct way. Yeah, I think they're going to try to trick you. Let's do it the correct way. So this is 10. And then square root of 2 times the square root of 2 is just 2. So that's 20. So I'm already at 20. And then this is going to be 4i square roots of 2. And then this is going to be 25i. Squeeze me. This is minus. There's where I almost made a mistake. This is actually a minus 4. Because notice it's positive 2 times negative 2. I almost made that dumb mistake. That's negative. So this is positive. I was just checking the signs out. This is positive 25i square roots of 2. And finally, 5i times negative 2i is negative 10i squared. Well, the thing you have to remember about I squared is that's really a negative 1. So negative 10 times negative 1 is really a positive 10. So I've got plus 10, so that's 30. And then negative 4i square roots of 2 plus 25i square roots of 2 is 21i square roots of 2. There it is. Which quadratic has the sum of the roots and the product of roots? Let's see. I'm out. Sorry about the coughing. My voice sounds a little froggy. It's okay. Sum of the roots. If you remember, the sum of the roots is equal to what? Is it negative b over a? and the product of the roots is equal to c over the a. Do you remember these formulas, c over a? So if the product is c over a, let's see, I need one that's going to give me, I need a negative 1 over 2 at the beginning. Oh, that's a little weird. Oh, wait, these are 3. So negative, I need a negative, so it can't be this one, and it can't be this one, because I need a negative c, because my c is negative, so there's 1/2. So if I use this one, this would give me, let's say I use this one. That would give me negative 3 over 6, which is negative 1/2. And if I use this one, that also gives me negative 3 over 6, which is negative 1/2. So it's got to be one of those two. And then if I use the product of the roots is just c over a. Whoa, 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 whoa. Yeah. Yeah, now I got to do sum. Sorry, got my head on my butt. All right, so this is the sum of the roots. Whew, thought I made a mistake. Then I realized I didn't. That's scary. Remember, the sum of the roots is negative b over a, but I'm looking for it to end up being positive. That means that my 7 had to start as negative, and then this would be the right answer. Because negative b here would be 7. That's negation of negative 7 over a, which is 6. 7 over 6. So the answer is choice 3. The range of this function. Now, this is in vertex form, which means the vertex is positive 4, negative 5. And if you graphed it, you would see positive 4, negative 5. 1, 2, 3, 4, 5. You would see something that looks an awful lot like this. If I went over my graphing calculator, it would look an awful lot like this. Well, remember, range are the y values, so this doesn't make any sense and this doesn't make any sense. Again, y or f of x values. So I need my lowest f of x value, or my lowest y value, which is right here at negative 5, and it goes forever and ever up. So anything greater than negative 5. Ka-ching, choice 4. Man, I haven't made a mistake yet. The graph of the equation y equals m to the x passes through. Well, this looks like it's an exponential function, right? Because the exponent is a variable, and we know all exponential program go to that point 0, 1. So is that a choice? 0, 1? Of course not. So let's see. If I plug in 1 for x, I get m to the 1, which is just m. So that looks pretty good. If I plug in a 0 for x, anything raised to the 0 power is 1, so that would give me 0, 1. That's not going to... If I plug in m for x, I get m to the m, which clearly ain't 0, and this would be m to the m. So here's your answer. 1 to the m. You plug in 1 here, you get m. That's it. I mean, that's a kind of a silly question, I guess. So if sine is 1/2 and it terminates in quadrant 2. All right, so sine is 1/2 and the angle turns in quadrant 2. So sine of 1/2, or sine of an angle, I know it's got to be a reference angle of 30 degrees, but it's ending in quadrant 2. But it's got to have a reference angle of 30 degrees. Still with me? All right. So sine is opposite over adjacent. This is 1 over 2, and then that makes this the square root of 3, because it's always got to be the square root of 3 and 2 and all that crazy stuff. All right, let's see what we got here then. I want cosecant, which is really 1 over sine. Oh, wait a second. I already know what sine is. Sine is 1/2. So cosecant is just 2 over 1. Cotangent is adjacent over opposite. So adjacent, which is the square root of 3, over opposite, which is 1. Square root of 3 over 1. So this just becomes 2 square roots of 3, which is... I made a mistake. But luckily for me, there wasn't an answer that was just 2 square roots of 3. There's only one of them, and it's negative. And the reason it's negative is because cotangent is negative in this quadrant. So this should have been negative radical 3 over 1. I apologize about that one. Now, having said all that, I could have did the inverse sine of 1/2 and got 30. Realize this was 30 degrees. Come over here and say, okay, if that's 30, then this has to be 150. And then I could have done on my calculator the cosecant of 150 times the cotangent of 150. And you'd end up with negative weird answer, which is the same as that. Weird, weird, weird. Another way to do the problem. Hope that helped. Well, here we go. 22. I just listened back at the beginning part of that last video. I apologize. This voice and that coughing must sound really awful in that microphone in your ears, so I apologize. Let me draw it. Let's go. A circle has a radius of 12 units. Okay. For the circle, which expression incorrectly, you guys are incorrectly and you're not. Thank you, New York State, for trying to confuse us and trick us. Incorrectly states the length of the arc. Now, as soon as I start looking at arc length, I know I'm talking about S equals theta r, and I know theta has to be in radians. So, which one of them incorrectly by the given central angle? So, in this case, the central angle is 120. Oh, you guys are not nice. So, in order to do this, I got to convert this to radians. So, I'm going to multiply by pi over 180. And if I do that, I get, let's see, 12 over 18 is 2/3. This is 2 pi over 3. So, S equals, well, let me just keep going here. So, S equals 2 pi over 3 times 12. Well, let's see, 3 goes in there 4 times, so that's 8 pi. This is correct, so it's not the right answer. I'm looking for the one that's wrong. I think it's going to be this one. And I'm like 100% sure it's 2. But let me do these. This is the answer. But let me check. This one would be 2/3. So I've already got it in radian measure, so I'm just going to do 2/3 times 12, and 2/3 times 12 is 8. And this one's already in radian measure, pi over 3 times 12, which is, let's see, 4 pi. Now the reason this one's wrong is because then I have to take 6, I got to multiply by pi over 180, and that gives me pi over 30 as my angle in radian measure. Well, if I do that, pi over 30 times 12, I'm definitely not getting 72. So this is the right answer because it's wrong. It's the right answer because it's wrong. Only in New York State. How many, now this one was a little bit tricky and they tried to fool you. How many 4-letter arrangements can be made? Now if you just said 1, 2, 3, 4, 5, 6 and you did 6 factorial, you might have chosen 720. It's not 720. It's clearly not going to be over 720 because I only want to do 4. So this is 6, choose 4. And so I got to go to my calculator and do this one. Where are these things? I don't even remember. Menu, probability, oh, there it is, combinations. So 6, comma 4, and I get 15. Whoa, 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 whoa. How many different? Oh, this is not choose. This is not, how many different, because each arrangement is different. So it's not P, it's not C, it's P. So there's actually 6P4. Boy, I'm surprised I didn't have that as the wrong answer. I could have been really messed up. Excuse me, kiddies. It's permutation. 6, comma, 4-bagger. And we get 360. 360, choice 1. You could have also just done this. 6 times 5 times 4 times 3. Because that's 4, that's 30 times 4 is 120 times 3 is 360. So the answer is 360. Which statement correctly describes the relationship between the two test scores? Oh my gosh, I got to do the mean of these things. All right, I'm going to pause this while I do the mean. Oh, gosh, bless it. I got to do mean in. All right, well, what I would do is come over to my calculator, go here, and what are these people's names? Let me look. I'm going to just do it. I'm going to look at my sheet over here. This is Michelle. 71, 68, 84, 88. Luckily, so I go menu, statistics, stat calculations, 1 variable statistics, click OK. I'll choose Michelle, click OK. So there's the information about Michelle. Her X bar is, Or that's the mean is 77.5. What else do I need? Oh my gosh. Michelle's mean test score is greater, and her test scores have a greater interquartile. Well, let's see what Valerie is. So let's go home, go back in. We're going to do now Val. Oh, I can't use Val. Sorry. Let's go Valet. Maybe I can do that. All right, 78, 82, 78, 82. Probably could have done this one by hand. 76, probably would have been easier. 80. Menu, statistics, stat calculations, one variable statistics. Okay, we're going to use Val this time, so make sure you pick, we're going to put Valet. And she's got a mean of 79. So X bar of 79. So Michelle's test mean score is not higher. So Valerie's mean score is higher. Valerie's mean tested score is greater. So both those. Michelle's population standard deviation is greater, but her range is smaller. Well, the range here is from 68 to 88. That's 20. And her range is 76 to 80, which is 4. So Michelle's range is greater. Michelle's population standard deviation is greater, but her range is smaller. Her range is not smaller, so that's not true. Her interquartile range. Well, let's see what her interquartile range is. Let's see. It's Q3 minus. So her interquartile range is from 81 to 77. That's 4 for Val. So her IQR is 4, and the other one's going to be much higher. Her IQR is 86 to 69, so that's like 16.5. Her IQR is 16.5. Valerie's mean test is score, and her interquartile range is greater. Her interquartile range is not greater. It's got to be choice 4. It's choice 4. And if you look at their population standard deviations, her population standard deviation is 8.4 for Michelle, and for Valerie it is 2.2. And notice how much wide range these are. I mean, you should have known that this was going to have a much higher standard deviation just looking at the numbers. All right, let's do this one last one. A wire supports long as from typical utility pole to point on ground 17 meters. So here's your pole. 17 meters. So the wire, a support wire 20 meters long runs from the top. So this is 20 meters. It's attached on the ground 17 meters away. To the nearest minute, find the angle formed by the pole and the wire. What? What is the measure to the nearest minute of, a support wire 20 meters long runs from the top of a utility pole to the point on the ground 17 meters from the base of the pole. What is the measure to the nearest minute of the angle formed by the pole and the wire? Oh, up here. Oh, they're looking for this. The pole and the wire. They don't ask that often. That's kind of tricky. All right, so we're going to look for this. Well, if that's an angle, let's see, this is the hypotenuse, this is opposite, and this is adjacent. So O and H is sine. So sine of x is equal to 17 over 20. So I got to do inverse sine. So inverse sine of 17 over 20. So that's what I'm going to do. Got to go to my calculator. Inverse sine. Oh, crap. Let me try going to calculator. Inverse sine of 17 divided by 20. Enter. I'm going to DMS this. So go in here, hit D. Let's see if it'll just let me DMS it. DMS. This is a weird calculator. I've got a weird calculator. I apologize. Hopefully it'll do it. I don't know why it's not doing that. Anyway, the answer is 5813. You would have gotten 58.12 and then a number that rounded to 13, and the answer is 58. I have no idea. This is a strange calculator I got it kind of new. I don't know why it's doing F parts. So that's a little weird. It's gone into crazy mode. So let's ignore that. All right, I'll be right back. Alrighty, kids. So, haven't seen this one in a while. So here's what we got. We got f of f inverse of x. Another way to think about it is f of f inverse of x. Or another way to think about that is f of, well, what is f inverse? X plus 2 over 3. So, this is really like my big X here, right? This is my big X. That's what's going to go in for X here. So this is equal to 3 times X plus 2 over 3 minus 2. Well, the 3's cancel, and I end up with X plus 2 minus 2, which is just X. And that's always going to be true, I guess, if they're inverses of each other. If they're actually inverses of each other, then they're going to always equal X. So that's kind of a dumb question. I didn't even know they were going with that, but that's it, I guess. That's the answer. Which graph represents the inverse of X? Now, if you remember correctly, inverses are reflections over the line y equals X. So if I draw that line in y equals X, there it is. And I graph this and I reflect it. This point here is going to go to 1, 0. Now, it's kind of hard to still look at. You got to think about it. So let's see. This point would go here. And would it? That doesn't look right. This point, let's go here. We'll go here to here. So it would come out about the same. So that would go here. Oh, so I think what's going to happen is we're going to get this. And does that make sense? Is this distance here about the same as this distance here? So yeah. So that's a tricky one. That's a tricky one. So I'm looking for the one that goes like that. So it's got to be choice 4. Choice 4, there it is, choice 4. And that ends the multiple choice, kiddies. All right, yay. All right, hit the subscribe button, hit the like button, let your friends know about it. By the way, we're going on to do AP Statistics and I believe AP Calc next.